So I was messing around a bit off camera and I just wanted to show you a quick thing. This is one of the circuit boards from inside the machine. These are one-sided, hand-drawn boards. So this is how old this machine is. They didn't even use a computer software to actually lay out the circuit boards. It's all done by hand. Let me just bring you in a bit closer. I have no idea if you're gonna see what I'm doing now, but I'm trying to attach the negative lead. Now I'll try to install the same nut on the other side. Down in there. Oh, only took like 20 minutes. So I managed to find the schematic of this circuit and how all of these knobs are connected to the circuit boards. Now, and according to the schematic, pin 10 of connector J5, which is this one, is supposed to be connected directly to one of the pins on the potentiometer. And it should be this one. Like you see, no resistance at all. Now the other side of the potentiometer should read 100k, which it does, more or less perfectly. Now, according to the schematic, 2 pins of the potentiometer are connected on the circuit board a bit further away. And that is the center pin connected to the wiper and the pin closest to me, or the furthest away from the camera, depending on how you want to see it. So here we also have 0 resistance. Now if I measure between pin 1 and the wiper, here, you can see the potentiometer works perfectly. And the only thing I did was remove the bodge solder someone had put in before, the one I showed you in the beginning. So I think now I should have a variable slope down between 0 and 5 seconds and not just have it stuck at maximum. I guess we'll see when I turn it on. I really should have filed more. So let's turn it on and see how it works. Well, nothing blew up, that's a good sign. Yeah, so in case you hadn't guessed that, it's not supposed to do that. I'll have to take it apart again. I think I might have found the problem. If I'm lucky. Yeah, I found it. It's probably a good idea not to have it set in remote when you try to turn it on. Without a remote, that is. I still have to get those connectors to seal properly, or to make contact, I mean. But that shouldn't take too long. Yeah, so I found one of the issues. Apparently some of those solder joints broke up when I were messing with the circuit board. Sometimes you just leave it well enough alone, but if you're curious, you are. I'm gonna try to get you in close and see if you can see it. So you have... there we have one. There's another one. I think that one as well. And we have focus. Two there as well, I think. So I'm going to re-solder all of these pins, and then we'll try again. So one of the best investments you can make if you're going to solder stuff like this is one of these flux pens. This is a lead-free flux dispensing pen. It's awesome because rarely the flux in the solder itself is enough on these old things, or old circuit boards, I should say. So just wipe it on. And you're good to go. So, I think that should be okay. Yeah. So unfortunately this is gonna have to be part 1 in this series, because I don't know how, but I somehow messed up something reassembling the welding machine, so I don't have a slope down on it. That's kind of sad, since I got this welder specifically because it had a slope down function, which my cheap Chinese welder didn't have. But then again, this machine is purely analog electronics. There's like no microcontrollers, nothing digital about it. So it should be possible to fix it. My best guess right now is that one of the capacitors has blown up. Or not blown up, but wore out, let's say. So I'm gonna see what I can do about fixing that. And in the meantime, take care, make something fun. So I managed to fix the slope down on my welder. It was what I thought. It was a capacitor that had gone wonky on me. It happens when they get old and they start leaking DC current instead of storing energy. Now this was a lot quicker than I thought, actually. I thought it would take like a couple of days and maybe finding some schematic or whatever. But I managed to find a capacitor that was a short circuit in it, replaced it with one with about the same rating that I had laying around, and now it works. So I bodged in this capacitor here instead. And where did I put it? Ah, here. Over here we have the original one that got wonky on me. So it had a DC resistance of about 42 ohms, and it should be in the megohm range at least, if any. Luckily enough, like I said before, I never throw anything away, so I actually had a capacitor of the correct rating laying around. It's about, or not exactly the correct rating, it's about 5 volt less on the voltage rating than the one that was there, but it still works perfectly fine. So, but I noticed another thing as well. You can see here, I hooked up my amperage plier to actually validate it, to see if these numbers here on the welding current were correct. As it turns out, they're not, but they're a bit off, but not too much. So when I have it set at 20, it gives 20 amps, at 80 it gives 50 amps, at 100 it gives around 90 amps, and the maximum setting is 160 instead of 180. So my guess here is that this actually have the same cause or source as the slope down getting messed up. That these capacitors over here are wonky as well, and probably these ones here as well. I mean, all capacitors wear out. It's one of the most common failures in power electronics, or in electronics at all. I mean, if your TV breaks down, it's probably a capacitor that blew up or got damaged just from overuse, from age. Especially electrolytic capacitors, because they have an electrolytic fluid inside that dries up. At least that's the way I got it explained to me like ages ago. So if you find a capacitor that has an end like this, let me see, yeah, if this end isn't flat but bowed out, the capacitor needs to be replaced. Or if you take a multimeter and you can measure a low resistance across it, less than 1 or 2 megohms, then it needs to be replaced. And in analog electronic or analog circuits, capacitors are more or less used as timers. They store energy and then they release it over a resistance, and depending on the resistance and the size of the capacitor, it takes different amounts of time, which means that the timing is off. And also, it might also help to set actually a reference current for a thyristor or some other power electronics in this thing that gives me the welding current. That's why I believe, I mean, I'm no expert in electronics, I'm just a happy amateur when it comes to electronics, really, but I believe that might be the cause of the power setting not being correct. Now, the power setting not being precise, it doesn't really matter that much, because I can validate it, and I can simply put in new numbers instead of the ones that are on here, and I never really need to go above maybe 120, 130 amps here in my home shop, my garage. And if I need to do that, I'll probably borrow a welder from work anyway. One with a water-cooled, take it towards water-cooled handler preferably. Because if you go above 120, 140 amps, it gets really toasty in the handle. So anyway, so I'm gonna call this a success. I mean, I fixed everything I found was wrong with it. Even the things I broke myself. So until next time, do something cool, build something funny. Take care.